Okay, so now that we've seen how to use the midpoint rule in this example, so let's see how to do the midpoint rule in general. Okay, so the problem is to approximate this definite integral using n equally spaced subintervals from a to b. So you start with your whole interval from a to b, you subdivide it into subintervals, and suppose we mark off the ith endpoint x of I and the previous endpoint x of I minus 1. So here, this is the width of the subinterval, so that's delta x. This is the midpoint of the subinterval, m sub I, and the height is given by the function value at that point, so f of m sub I. Okay, so to calculate the width of the subinterval, it's the same as we did before. So you take the whole width, which is b minus a, and divide by the number of subintervals. So you get b minus a over n. Then to get the ith endpoint, you start from a, you count over I subintervals. That will be a plus I times delta x. Then the midpoint is just the average of the two endpoints, so x of I plus x of I minus 1 divided by 2. And then the height, again, is the function value at the midpoint. Okay, so the definite integral is approximated by the sum of these rectangles. The area of each individual rectangle is the function at the midpoint times delta x. And then we do that for each rectangle. And then so this can be written in shorthand notation as the sum from 1 to n of the function value at the midpoint times the width delta x.